Coordinating electrical drawing systems with other disciplines, such as architectural, structural, mechanical, and plumbing, is essential to ensure a cohesive and functional design. Here are the main rules for effective coordination. 1. Early and continuous communication. Integrated design meetings. Hold regular coordination meetings with representatives from all disciplines to discuss design progress and resolve potential conflicts early. Shared platforms. Use collaborative tools and platforms, like BIM, Building Information Modeling, to facilitate real-time updates and communication. 2. Consistent standards and conventions. Adopt common standards. Use the National CAD Standard, NCS, or another agreed-upon standard for layer naming, symbols, and annotations to ensure consistency across all drawings. Uniform units and scales. Ensure all disciplines use the same units, e.g., metric or imperial, and scales on their drawings. 3. Clash detection and resolution. 3D modeling and clash detection tools. Use tools such as Autodesk Navisworks to identify and resolve clashes between electrical systems and other building components. Clearance requirements. Ensure electrical conduits, panels, and fixtures have adequate clearance from structural elements and other services. 4. Detailed coordination drawings. Coordination plans. Create coordination plans showing the layout of electrical systems in relation to mechanical, plumbing, and structural elements. Elevation views and sections. Provide elevation views and sections to illustrate the vertical relationship between systems and to avoid conflicts in ceiling spaces, walls, and floors. 5. Clear documentation and markups. Markup drawings. Use color-coded markups to highlight changes, conflicts, and critical coordination areas. Detailed notes. Include detailed notes and legends on drawings to explain coordination requirements and any special installation instructions. 6. Review and approval processes. Review cycles. Implement regular review cycles where all disciplines review each other's drawings for potential conflicts. Approval workflow. Establish an approval workflow where changes are reviewed and approved by relevant stakeholders before implementation. 7. Space allocation and routing. Dedicated spaces. Allocate dedicated spaces, e.g., electrical rooms, riser shafts, for electrical systems to avoid conflicts with other services. Pathways and routing. Plan pathways and routing for electrical conduits and cables that consider other disciplines' layouts, avoiding areas with high congestion. 8. Compliance with codes and regulations. Code compliance. Ensure all designs comply with local building codes, electrical codes, e.g., NEC, National Electrical Code, and regulations which may also impact other disciplines. Safety standards. Coordinate safety requirements such as fire ratings, emergency lighting, and power systems in conjunction with other disciplines. 9. Flexibility and adjustments. Design flexibility. Allow for flexibility in the design to accommodate changes from other disciplines during construction. Field adjustments. Be prepared for on-site adjustments and maintain open communication channels for real-time problem-solving. 10. Documentation of changes. Changelogs. Maintain a changelog documenting all modifications and their impacts on other systems. As-built drawings. Ensure that as-built drawings accurately reflect all coordination changes made during construction.